Welcome to LeetCode Problem 2, Add two numbers. In this problem, we are given two linked lists that represent numbers in reverse order. While that might sound confusing at first, it's actually a massive advantage. Because the lists are reversed, their heads perfectly align at the least significant digit, the ones place. This means we can add them in a single, straight pass from left to right, exactly how we carry over numbers in standard paper and pencil edition. Let's look at the setup. To make building our result list completely seamless, we initialize a dummy Sentinel node. This elegant pattern prevents us from needing messy conditional checks for the very first node. We also set up a current tracking pointer to build the tail and initialize our carry buffer to 0. We enter our main loop as long as there is a node in list 1, a node in list 2, or lingering carry. For the ones place, we start by adding the values of the first nodes, 2 plus 5 plus our carry of 0, giving us a working sum of 7. We use integer division by 10 to calculate the next carry, which stays at 0, and modulo 10 to extract the digit 7. We create a new list node for this 7, link it up, and advance our pointers. Moving to the tens place, we add 4 and 6, which gives us a sum of 10. Here is where the modulo mouth shines. 10 divided by 10 gives us a new carry of 1, and 10 modulo 10 leaves us with a stripped node value of 0. We link the 0 to our output list and hold on to that 1 in our carry register for the next column. Now for the hundreds place. We add 3 and 4, but we must also add our active carry of 1 from the previous step. This brings our total sum to 8. Our carry drops back to 0, and we link the 8 to the tail of our growing list. At this point, both input lists are empty, and our carry register is 0. The loop terminates naturally. To yield our final answer, we simply return dummy.next, neatly skipping our initial placeholder. And we're done. Because we process both lists together in a single parallel pass, our time complexity is strictly linear, big O of max n, m. Our space complexity is exactly the same, as the size of our constructed list scales directly with the longest input. Thanks for watching.